Okay. So, hello everyone. So, I hope I'm audible and visible. So, so basically today's lecture is named Physics Sure Short Questions. So, in this lecture, we are going to mainly cover the most important topics that appeared in the January attempt of JEE. So, we will begin the session like in 2 minutes. Okay. So my name is Gokul. So this is my first lecture here on PWJ English. So I've done my graduation from IIT Madras. Okay, and I'll be covering physics for you guys. Okay, so mainly today's agenda is to cover the sure short problems. Okay, so these are going to be the important questions that appeared in JEE Jan attempt. Okay, so yeah, so we can start with the first problem itself. So I guess a few students are here. So we can begin, yeah. So I hope this is visible, the question is visible on your screen. Okay, so yeah, the first problem is based on finding the RMS current of a time varying current. Okay, so we have been given a current that varies with time, something like this, as I naught T divided by capital T. Okay, so we have to find the RMS current for the period from T equal to 0 to T equal to capital T. Okay, so that is the first problem. So how do we do this? So the RMS current, in order to find it, so RMS is root mean squared, right? So the way we do it is first we find, so RMS, so this would be root mean squared, right? So firstly we will square the value of current. So this current is a function of time. So first we'll square the value of current. Okay, so that is the square part, and then we'll take the mean of it. Okay, so we'll square the current function, then we will find the average value of this I square function from T equal to 0 to T equal to T, and then we will take the square root of it. Root means squared. Okay, so this is the definition of the RMS current value. Alright, so we can start by firstly writing down I square. So what will I square be? Just square this function. So I square is going to be I naught squared divided by T squared times small t squared. Okay, this is the I square function with time. And now we will take the average of it. So how do you find the average of any function? The average of I square is simply going to be the integral of I square dt, and we want the average value in the time interval from 0 to t, right? So we will integrate this from 0 to t and then just divide it with t. So this is the process behind finding the average value of I square. Okay, so now let's just substitute everything. So I square would be I naught squared divided by t squared times t squared. This is the function we calculated in the last page. Okay, now we'll integrate this with respect to time from 0 to t. Okay, this is the I square dt integral, and we'll divide it with capital T. So once we solve this integral, Sumit sir is still here in PW, so we are both going to be taking classes together. So Sumit sir is still here, guys. Okay, so yeah, hello Vikram, welcome. So yeah, we are in the middle of solving this question, so first we'll solve it. So yeah, so here I naught and t are constants, right? So we can take it out. So it will be I naught square divided by t square, and then we have the integral of t squared, which is straightforward. It is t cube divided by 3. So we'll just put the limit as well. There is also a t here, the denominator, right? So this would become t cube divided by 3, the integral. Okay, so the t cube cancels out, and the final value will become I naught square divided by 3. So we just determined that the average value of I square in the interval from 0 to t is going to be I naught square divided by 3. Okay, so okay, so yeah. Okay, so now we have the average value. So now we'll just take the square root. Okay, so if we take the square root of this, this is simply going to be the IRMS value. So first step is to find I square function. Then we find the average using integrals. Okay, and then we take the square root, and finally we get the IRMS. Okay, so this would simply be I naught divided by square root 3. Okay, so it's a straightforward math question. So okay, yeah, it's okay to watch the recorded version as well. That also helps to like solve, right? You guys can just pause it and solve it with me. That is also fine. So yeah, your physics is weak. So for physics, I would say like mainly if you can, you know, learn the pattern of questions, because a lot of questions are simply just formula based, right, which appears in JEE Mains. So I would say you can just watch lectures like these, you know, and learn from the pattern of problems. So for example, a certain type of problem if you are seeing, just learn how that is solved. The method itself will be enough. Like you don't need that much advanced level for JEE Mains, right? Most of the questions, as we'll see, even if you just know the formula, you can easily solve it. Okay, so I guess that is good for this question. So the answer was I naught by root 3. So is this question fine, guys? So it's a straightforward question only, right? Okay, so yeah, I will explain the basic theory, Shekhar, before solving it. So yeah, I guess that is it for this first question. Okay, so this is the second question. It's a problem on just rotational mechanics. Okay, so here we have a thin uniform rod. So as you can see over here, its length is L and it is pivoted at a height L by 3. Okay, so the pivot is over here at this location. Okay, so at this location the rod is hinged, which means the rod is about to rotate about this axis, this horizontal axis, and this distance of this pivot from the edge is actually L by 3. So that is the situation. So now the thing is, the rod is allowed to fall from this vertical position, and so now you can imagine like this rod is going to rotate and eventually it will come to the horizontal position, right? So the question is, when it reaches the horizontal position, what is the angular velocity? So when the rod will reach the horizontal position, something like this, before colliding with the table, it will have some angular velocity. So the question is to find out this angular velocity. Okay, so this is a very standard problem. The main idea here is simply energy conservation, right? So whenever we have to find omega, most probably it's just going to be energy conservation that is being applied. Okay, so the way to think about this is, there is, when initially the kinetic energy of the rod is 0, lecture duration would be about 2 to max 2.5 hours. Vikram, okay. So yeah, so we'll just do energy conservation here. So what exactly is energy conservation? It's basically Ui plus Ki equals Uf plus Kf, okay. And here U is the gravitational potential energy and K is simply the kinetic energy. So this is a simple fixed axis rotation problem, right? So initially, for writing down the potential energies, we need to know where the center of mass is. So we'll just choose this horizontal level where the table is as our zero potential energy level, okay? 0 PE level. So what will happen is, initially the center of mass is not at the hinge, guys. The center of mass is above, because this is a thin rod, right? This is a thin uniform rod, so the center of mass will be at L by 2. from the bottom end of the rod, the center of mass will be at L by 2. So we can make a different diagram because that diagram is not that clear. So this is our rod and the hinge was at this point somewhere over here, okay. So this length was given to be L by 3. So we know that as this is a thin uniform rod, the center of mass will be at L by 2 distance. So the center of mass will be somewhere over here and this distance is L by 2. Okay, so what is the distance of the center of mass from this hinge point? So that will be simply L by 2, the total distance, minus L by 3. So which is going to be L by 6, right? So initially the center of mass is L by 6 above the table's level. Let's draw the table's level using dotted lines. So this was the table's level. Okay, so the center of mass is L by 6 above. Now what will happen? The rod will rotate clockwise. Okay, and when it reaches the horizontal position, situation will look something like this. Okay, so I guess the initial situation and the final situation is now clear. So yeah, of course, when this rotates, this distance will now be L by 3 and the rest of the distance will be L by 2L by 3. Okay, so this is the initial situation and this is the final situation, and over here the rod will have some angular velocity omega. So this omega is what we have to find. Okay, so in the final situation the center of mass is exactly at the horizontal level. Okay, so center of mass was initially at L by 6 height from the table's level and finally it reached the table's level. So if I ask you what is the change in gravitational potential energy, this is simply mg, where m is the mass of the rod, times change in the height of center of mass. Okay, so center of mass was initially L by 6 above and finally it is at the table's level. Okay, and we chose the table as the zero potential energy level. So if I have to use ui plus ki equals uf plus kf, initial potential energy is mg L by 6, right? So mg L by 6 is the initial potential energy. What is the initial kinetic energy? The rod started from the vertical position, right? So initial kinetic energy would be 0. And finally, the center of mass is at the same horizontal level as the table. So the final potential energy will be 0. But finally, the rod is rotating with some angular velocity, right? So whenever we have a rigid body that is performing fixed axis rotation like this, the kinetic energy is written as half I omega square. Half I about hinge times omega square. Okay, so now if we find the I about the hinge, we can easily find the answer. So what will I about the hinge be? So for this we have to use parallel axis theorem. So we know that the moment of inertia about an axis passing through the center of mass, right, is actually ml square by 12. Okay, so in the parallel axis theorem term, this ml square by 12 is the ICM, okay, moment of inertia about the center of mass axis, horizontal axis. So to this we have to add the mass of the rod m times d squared, where d is this distance between the center of mass and the hinge. Okay, and this distance we determined it was L by 6, right? So to this ml square by 12, we need to add m into L by 6 whole squared. So what will this be? This is ml square by 12, this is ml square by 36. So this will be ml square by 9. Okay, so this is how we find the moment of inertia about the hinge axis. Okay, all right, so everything is clear, I guess. Okay, so yeah, once we get IH, now we have everything, right? We can just substitute. So mg L by 6 equals half moment of inertia about the hinge, which is ml square by 9 times omega squared. Okay, so this cancels out and we get omega square as, so L and M goes, this will be 3g by L and the angular velocity will be square root of 3g by L. Okay, so in problems like these where we have to conserve energy, the main point is that you need to see, the change in height level of the center of mass. Mg into delta HCM will give you change in potential energy of the rod. And for change in kinetic energy, for fixed axis rotation, the kinetic energy will simply be half I omega square. Okay, so that is it for this question. Answering of shift 1, I think Sumit sir will cover that. Let me see if I'll try to be part of the other ones. Okay. All right. So this question is complete. So now we have the third question. So this is a question based on nuclear physics. Okay. So here we have an atom and it is bombarded by a shower of fundamental particles. Okay. And in 10 seconds, the atom absorbed 10 electrons, 10 protons and 9 neutrons. So initially the atom had 3 protons and its mass number was 8, right? So after this particular process, the atom, the nucleus will have 10 more protons and 9 more neutrons, okay? So now the question is, what is the growth, percentage growth in the surface area of the nucleus, okay? So this is a pretty classic result, and that is the radii of the nuclei. The radius of the nuclei, this is in fact proportional to the mass number of the nuclei raised to the power 1 by 3. Okay, so this is a formula which most of you must be knowing, right? If you have covered nuclear physics. Okay, so you got it wrong. Yeah, it's very easy to get it wrong because it's hard to, solve all the steps correctly. You can easily make calculation mistakes while solving such problems. But anyways, okay, so yeah, so this is the result we'll be using. So here R is of course the radius of the nuclei, radius of the nuclei or nucleus, and here A is the mass number. Okay, so the thing is, when the atom eats up more protons and neutrons, right, it will increase in its mass number, and as the mass number increases, the radius of the atom or the nucleus will also increase. So they are asking what is the percentage growth of the surface area due to this particular process. That is the question. Okay, so this is the only result we'll be needing. So we'll get rid of the proportionality by putting a constant. So we'll say the initial radius, let's call it R1. This is equal to some constant C, mass number to the power 1 by 3. So initially the atom is having a proton number, or the number of protons is 3, atomic number, and the mass number is 8. Okay, so this 8 is the mass number. So we'll plug it in over here. So it is 8 to the power 1 by 3, right? So this will become 2C. This is the initial radius. Now for the second radii, the mass number will change. So mass number, exactly what is it? It's the number of neutrons plus protons present in the nucleus, right? So it ate up 10 extra protons and 9 extra neutrons. Originally it had 8, so the new mass number will be the original 8 plus the new 9 plus 10, which is 19. So this is going to be 27. So this 27 is the new mass number, right? So the new radius will be the same constant c times 27 to the power 1 by 3. Okay, and this will be 3c. Okay, so I hope the radiuses are clear. So basically R2 by R1, if we try to find, it will be 3 by 2. Okay, so the final radius divided by the initial radius is 3 divided by 2. So now what we'll do is we need the surface area story, right? So we'll square it. So the surface area, let's use the symbol S. So S2 divided by S1, this will be proportional to the radius squared, right? So this will be R2 by R1, the whole squared. And so this will become 9 by 4. Oh yeah, also this is a 2026 problem, and I think none of the options are correct. Okay, so yeah, we'll see that. So the surface area ratio is 9 by 4. Okay, so basically S2 is, what is 9 by 4? It's 2.25. So 2.25 S1. Okay, so new surface area is 2.25 times. Okay, so should I speed it up a bit, Nabil? Okay, so I'll pick up some pace. Okay, so the new surface area is 2.25. So yeah, we have some, I brought some questions like around 40 to 45. So we'll cover those in detail. Okay. So yeah, so once again, S2 is 2.25 times S1. Now the question is, what is the percentage increase in the surface area? Okay. So percentage increase in S. So percentage increase, we calculate it as delta S divided by the original surface area. So what is delta S? It is S2 minus S1 divided by S1. So S2 was 2.25 S1. So this will become 1.25 S1 divided by S1. So this is going to be 1.25. Okay, and for percentage, we'll multiply this with 100. So the answer will be 125%. Okay, so this is the increase in the surface area. In fact, like none of the options actually matched. This was a JEE January question. Okay, so that is it. So I guess we can pick a little speed. Okay, so all right. So yeah, this is a typical motional EMF example. Okay, so we have 1 meter length rod, and it is moving with a speed v. Okay, so in this situation, we know that the motional EMF will start acting, and the direction of the battery is given to us by V cross B, right? So V is towards the right, B is into the page. So if you do V cross B, the positive direction or the V cross B's direction is in the upward direction. So the battery opens up something like this, okay? And there will be counterclockwise current like this. So this is most probably known to you. And then the question is, the resistance is given. The question is, what is the force that we need to move the rod with constant speed? Okay, so constant speed. So speed, if it is being constant, then this of course directly means zero acceleration. And what does zero acceleration mean? The net force is zero. Okay, F net is zero. Alright, so now the thing is, we have a current carrying conductor moving along the x direction, and there will be a current, right? So a current is in this particular direction, I. So when we have a current carrying wire moving in a magnetic field, the magnetic force acting on it is given to us by IL cross B. Okay, so the magnetic force is given to us by I times L cross B in this situation. Okay, so the L is basically in the direction of current. So if you do L cross B, the answer will be towards the left. So the force due to the magnetic field acting on this current carrying wire will be towards the left. Okay, and what is its magnitude? Its magnitude, so here L vector and B vector are perpendicular to each other. So there will be a sine 90. So you guys would be knowing about it. And this force is ILB. Okay, so this ILB force, we have to overcome it. So the external agent will have to apply a force of ILB towards the right. This is the force applied by the external agent. Okay, so this is our answer. Good morning, Mickey. Hello. Yeah, I'm picking up some more speed. I guess I can speed up the calculations and explain the concepts to you guys more. So yeah, the external force is ILB. So now the thing is the current. So the current is simply, we just have to apply KVL in this loop, and it will be just the EMF divided by the resistance, right? What is the EMF? The EMF in this case, where we have a conductor moving with a speed V, is VBL, right? So VBL divided by R, this is the current. So now we can just put it into this expression. So the external force is ILB, and I is VBL divided by R. So this will be V B square L square divided by R. Okay, so I guess we can skip the calculation part. I think the answer would be either B or D. Okay, so yeah, so we can move on. Okay, so here we have the de Broglie wavelength of a deuteron, okay, and the kinetic energy is given, and similarly the alpha particle is also given and its kinetic energy is 2e. So we have to find the ratio of their de Broglie wavelength, okay. So that is the question, and they are given that mass of proton and neutron, that we typically just take it as equal, okay. So the de Broglie wavelength, this is just a standard formula. For a particle is simply the Planck's constant divided by the momentum, right? Now the game comes while writing the momentum. So this depends on what is given in the question. Sometimes they give the momentum is same for two particles. Sometimes they mention the kinetic energy is same. So here in this question, the kinetic energy ratio is known to us. So we'll write the momentum of a particle in terms of the kinetic energy. Okay, so what is it? It is going to be 2m kinetic energy K. Okay, h by square root 2m K. This is what the de Broglie wavelength will be for a particle. Okay, so now it's just about taking the ratios. So what we need is lambda of the deuterium atom divided by the lambda of the alpha particle. Okay, all right, so the h cancels out, 2 cancels out, and what we are left with is square root of mass of alpha particle times the kinetic energy of the alpha particle divided by mass of deuterium times kinetic energy of deuterium. Okay, so kinetic energy of alpha is given to be 2e, and the kinetic energy of deuteron is given to be e. So this ratio will be simply 2. K alpha by Kd will be simply 2. Mass of alpha particle is going to be 4m, because the helium nucleus, it consists of 2 protons and 2 neutrons. So the mass of alpha particle, we'll consider it as 4 times the mass of a proton divided by the mass of deuteron. So deuteron, nucleus of deuterium, it has 1 proton and 1 neutron. So its mass, we'll consider it as 2m. Okay, so now this cancels out. Square root of 4 is simply 2. So the ratio will be 2:1. Okay, so the answer for n will be 2. Alright, so this was a integer type question, I guess. So yeah, the answer for n will be 2. So that was this question. Direction of force is wrong. No, okay, so these two forces are different. This ILB is the force due to the magnetic field. Okay, so that is given to us by I L cross B. So I is in the upward direction, B is into the page direction. So if you do I cross B, it will be towards the left. This is actually the external agent, okay, who is applying a force towards the right. So these two are different. Okay, I think you mean like I wrote ILB towards the right. Is that the doubt? Okay, so the directions are correct actually. Okay, so let's move on. All right, so now we have a statement problem. So in this problem, the first statement, so we have to comment on which statements are correct, is like one correct, one wrong, etc. Okay, so the first statement is that we have an object that moves from position vector r1 to another position vector r2 under a conservative force field F. Okay, all right. So the work done by the force, they have given this particular expression. So yeah, it's fine, it's fine. Okay, so the issue with this is there is a minus sign here. Okay, whereas a work done by any force, it has a very clear definition. The work done by any force, irrespective of it being conservative or not, is simply the integral of force dot tiny displacement, and we have to integrate it from some initial position vector to final position vector. Okay, so this is the definition of work done by any force. Okay, but here they put a minus sign, and because of this minus sign, statement 1 is wrong. Okay, so statement 1 will be incorrect. Now for statement 2, what they're mentioning is any object moving from one location to another location can follow infinite number of paths, okay, which is true. If we have 2 points in space, right, r1 and r2 vector, you can go from r1 to r2 through infinite number of paths. Okay, that's what they have mentioned. But continuing, therefore the amount of work done by the object changes with the path it follows for a conservative force. Okay, and this is what makes it wrong. The definition of conservative force is that whichever path you choose, right? So going from some point A to some point B, whichever path you choose, the work done by the force F, right? Work done by this conservative force F will be the same. So whichever path you choose, the work done will be the same, and therefore the second option is wrong. Okay, second option is saying if you choose different paths, the work will be different. Okay, so the answer is both are false. Okay, so it will be D option. Okay, so I guess that is clear. All right. So yeah. So hi Prince, welcome. So yeah, so that was it. This question was straightforward. It was based on the definition of a conservative force. Okay. Okay, so now we have a YDSC problem. Here we have the simple YDSC setup itself. This is a classic setup which we usually discuss in classrooms. Okay, so this is a YDSC problem. So here the thing is we keep a glass slab which is very thin in front of one of the slits. So let's say we chose this slit and we placed a glass slab in front of this slit. Okay, and this thickness is given to be T. All right, and the slit width is given to be like 0.4 millimeter, and then we have the screen on the right hand side. The screen is over here, and this distance capital D is given to be 1 meter. Okay, so now the question is, when we introduce the glass slab or the glass sheet in front of one of the slits, then the center bring fringe, just read it as central fringe. Okay, the central fringe shifts by 20 mm on the screen. Okay, so the central fringe is the point which is at directly in front of the slits, which is at 0 path difference point, right? The 0 geometrical path difference point. This point is what we call as the central fringe or the central maxima. Okay. All right. So okay, so now what will happen is, in case the slab was not there, the central maxima would have been formed at O. Okay, and the main characteristic of the central maxima is that the path difference is 0, right? So if this path length traveled by the light wave coming from here, if this path length is, let's say, L, then the path length traveled by this wave will also be L, and basically L minus L gave us a delta x equals 0, which gave us the central maxima. Now the thing is, when we introduce the slab, it introduces an extra path length, okay, which is the optical path length, and because of that the answer changes. The central maxima is not at O anymore, okay. So this is the central maxima point. Now the central maxima will not be at O, it will shift. So let's say the transparent slab is placed in front of this particular slit, the upper slit, okay. So now what will happen is, because of this glass slab, an extra path difference will be introduced for the light wave traveling from here. So you can think of it like this. So this light wave coming from this particular slit, it kind of travels a slightly extra distance. It travels more distance because of this glass slab, because the refractive index of this glass slab is mu, and we know that the optical path length, so if we have a light wave traveling through this glass slab, the optical path length traveled by this glass slab, light, will be mu t if the thickness of the glass slab is t. But if there was no glass slab, this would have been simply t. So because of this extra path difference, the light coming from the upper slit travels a slightly more optical path. So which means the light coming from the lower slit needs to travel more distance, okay, which means the central maxima will shift upwards actually. So the central maxima will be somewhere over here, and this shift is what we have to find, okay. Let's say this shift is some y. This y, in fact, they have given us as 20 mm, okay. So now let's draw the diagram. So this light ray is going to be something like this, and this light wave travels this distance. So clearly this path is a larger path than this red path, but because of this glass slab, the upper light wave travels a slightly more distance, okay, because of the glass slab. It introduces an extra optical path length, okay, and hence ultimately what we have to do is delta x equal to 0. So let's just say this point is S1, this slit is S2, and this point is P, okay. So S2P, the optical path S2P minus the optical path S1P, this should be 0 for the central fringe, okay. So S2P is simply the geometrical length, okay, so whatever that may be, S2P. Now for S1P there is a slight trick here. So it's the original path S1P, but here there is an issue where we had the glass slab, right? Here what we'll do is we'll subtract that t from this S1P. So from this S1P length we subtracted this t length, okay, because there is no it's not vacuum there anymore, it's glass slab. So we subtracted the t and we added a mu t. Mu t is the new optical path because of the glass slab being present there. So this is going to be the new path difference, S2P minus S1P, okay, and this we have to set it equal to 0. Now here we have S2P minus S1P. This is the length, okay, this length minus this length. This will be equal to, so if we take it to the other side, it will be mu minus 1 into t. Mu minus 1 into t. Now this S2P minus S1P is given to us by the simple d sine theta formula, right? This is the stuff that we cover in Young's double slit experiment, the first lecture basically. So if this, let's say we draw a line here, and if this angle is some theta, this is a very small angle usually, right? Then the thing is we write this S2P minus S1P as d sine theta, okay. So if this slit width is d, then this S2P minus S1P we write it as d times sine theta, and this will be equal to mu minus 1 into t. All right. So Now the thing is, because this is a very small angle, why is this a small angle? Because y is very small, 20 mm compared to 1 meter, right? So this angle theta is a very small angle. So we'll use the approximation that sine theta is approximately equal to tan theta. Okay, and tan theta, we will say it is equal to this height y divided by this base length, which is capital D. Okay, so this will be equal to y divided by capital D. So now instead of this sine theta, we will put y by capital D. So y small d divided by capital D equals mu minus 1 into t. Okay, so that is basically the solution. So from here y comes out to be capital D times mu minus 1 into t divided by small d. Alright, so because of the introduction of the slab, it introduced extra path length over here, which is compensated by the second wave by traveling a larger distance. Okay, so and therefore the central maxima shifts above. Okay, so now we can just substitute. So D is 1 meter. Mu was given to be, mu will be, yeah, so mu is what we have to find. So mu minus 1, and the thickness was 20 micrometer. So 20 into 10 to the power minus 6. This thing divided by the small d distance, which is 0.4 mm. So 0.4 into 10 to the power minus 3. This is equal to the, what was the shift? The shift was 20 mm, right? So equals 20 times 10 to the power minus 3. Okay, so now I guess it's easy to solve for mu value. All right, so yeah, that is it for this question. All right, so this is a kinematics problem. So here we have water drops that are falling off a tap. And the floor is at a distance of 5 meter below the tap. Okay, so let's say this is the tap level and this is the floor. The distance between the tap's level and the floor is given to be 5 meters. Okay, so here we have some sort of a tap and drops are falling. Okay, so statement says the first drop that comes out of the tap, it strikes the floor when the sixth drop begins to fall. Okay, so the situation looks something like this. So this is the sixth drop. So the fifth will be somewhere here, fourth, third, second, and the first one hits the ground. So first, second, third, fourth, fifth, sixth. So sixth one is still on the tap. Okay, this is the situation they have mentioned. Now the question is, where is the fourth drop from the ground at the instant when the first drop strikes the ground? So at this instant, where is the fourth drop? So where is this guy from the ground? So that is the question. All right, so actually this will be the fourth drop, right? So this is the first, second, third and fourth. Okay, so we want the fourth drop's height from the ground. All right, so let's begin. So the first thing is that the first drop, when it fell from the tap, its initial velocity would have been 0, right? Because it's just starting to fall. So its initial velocity will be 0. So if something falls with an initial velocity of 0 and it falls, and we want the time it takes to fall by a distance of, let's say, 5 meters, that time we can get by root of 2h by g, right? So if you drop a ball with 0 initial velocity, it falls by a height of h in root 2h by g time. So what is the height that the first drop fell by? It fell by 5 meters, right? So 5 times 2, 10, 10 divided by 10 is 1. So the total time elapsed so far is 1 second. Okay, so this situation is actually 1 second after the tap was opened. So now the question is, this is also mentioned. At regular intervals of time. So the drops are falling drop by drop in regular intervals of time. So basically the first drop, so what that means is, let's say this is the situation when the first drop started to move from the tap. After delta t time, let's say the drop reached this point. So after delta t, so after this delta t time, the second drop starts to fall. After another delta t time, the third drop starts to fall, right? So the second drop falls after delta t, right? So if I ask you when is the third drop starting to fall, it happens after 2 delta t, where delta t is the time between successive drops dripping, right? So if I ask you when is the nth drop just starting to come out, you can just look at the pattern and say it happens after n minus 1 delta t seconds, okay? So first drop comes out at t equal to 0. After delta t time, the second drop comes out. After 2 delta t time, the third drop comes out. And after n minus 1 delta t, the nth drop comes out. So over here, the sixth drop is just coming out, right? The sixth drop is just coming out. So if we substitute it into this formula, the total time was 6 minus 1 delta t. This is the time that has passed. This will be equal to the 1 second time, because total time that passed was 1 second. So from here, we get delta t equals 1 by 5, which is 0.2 seconds, okay? So this is the time after which drops start falling one by one. So this at t equal to 0, first drop. After t equal to 0.2, the second drop starts. After t equal to 0.2 plus 0.2, which is 0.4, the third drop falls, and so on, okay? So I hope that idea is clear. So now if we have that idea, the fourth drop, this guy is who we have to check now. So this is the first drop, this is the second, this is the third, and this is the fourth. So how much time has passed since the fourth drop came out? And then the answer is, so fourth drop so far has spent a time of 2 delta t, right? So fourth drop before 2 delta t seconds was over here. After delta t it is here. After delta t it is here. So right now fourth drop has spent a time of 2 delta t falling. What is delta t? 0.2. So time under fall for fourth drop. This is 2 delta t. Okay, so and 2 delta t is 0.4 seconds. Okay, so if we have a ball that falls from rest for 0.4 seconds, the height it falls by, let's call it h. This h can be figured out using half gt square, right? It falls from rest, so the height fallen is half gt square. Now let's substitute, so half 10. So the time taken is 0.4, so 0.4 squared. Okay, so so this will be, so 5 times 16 by 100, so this will become 20, and this is going to be 1.6 by 2, which is 0.8 meters. Okay, so the fourth drop is actually at a height of 0.8 meters from the top. So now the question wanted us, where will it be from the ground? Okay, so from the ground we'll just subtract 5 minus 0.8. So from the ground the fourth drop is at a level of 4.2 meters. Okay, so that will be the answer for this question. All right. Okay, so okay, so let's move on. Okay, so now we have a electromagnetic wave. All right, so electromagnetic waves, electric field is given. So typically it will be of the form something like this. So it will have an E naught, which is a magnitude, and sine of omega t minus kx, right? So the form is something like this. E naught sine of omega t minus kx. So whenever you see omega t minus kx, this just means that the main wave, main electromagnetic wave, it's propagating along the x direction. Propagating along plus x direction. Alright, so that's the most important thing. Now the question is, what is the refractive index of the medium? So this question has nothing to do with finding the magnetic field and stuff. It's pretty easy. So the refractive index of the medium. So this wave is traveling in some medium whose refractive index is n. Okay. So what happens when a wave travels into a medium with a refractive index different than vacuum? The speed of the wave changes, right? So how do we find the speed of this wave? The speed of travel of this wave is given to us by omega by k, right? So omega is 2 into 10 to the power 15, k is 10 to the power 7. So if you divide it, you'll get the answer as 2 into 10 to the power 8 meters per second. Okay, now this v is nothing but the speed of light in vacuum divided by the refractive index, right? So this is what we do whenever we have a medium whose refractive index is n. In that medium, the speed of light becomes c by n. So now what we'll do is we'll take n to this side, v to this side. So our n will be c by v, which is going to be 3 by 2 basically. So 1.5. So this is going to be the answer. Alright, so this is a straightforward problem. So the main idea here is to find the speed at which this electromagnetic wave or light wave is moving. Okay. After that, that speed of light divided by that speed of the wave will give us the refractive index. Okay, so moving on. This is a magnetic fields problem. So here we have 3 current carrying wires. Okay, and they're separated. Their separations are also given, 3 centimeters and 2 centimeters. Now the question is, we have 3 current carrying wires arranged mutually parallel as shown in the figure. The force experienced by 15 centimeter length of wire Q. Okay, so this guy in the middle, what is the force he experiences on 15 centimeter of the length? Okay, so this is based on a very common result which we cover in class, and that is whenever we have like 2 current carrying wires. So this is wire number 1 and this is, let's say, wire 2. So these are 2 long current carrying wires and like their separation is, let's say, D. Now this also depends if, let's say, the currents in each of these wires are parallel to each other. Okay, so then you must be knowing that these 2 wires actually attract each other. So whenever we have parallel currents like this, they mutually attract each other. So the second wire attracts the first wire with some force F, and similarly vice versa, right? And this force per unit length of the wire, this formula is something that we discuss in class, and this is equal to mu naught I1 I2 divided by 2 pi d. So the force per unit length in a situation like this, when we have 2 current carrying wires, it is given by this particular formula. Okay, and this is pretty easy to derive also. You can easily find out the magnetic field due to this current carrying wire at the second wire, right? So because of this wire only, the magnetic field at the second wire's location is into the page, right? You can just use right hand rule. So over here the magnetic field will be into the page. What is the magnitude of that field? Mu naught I1 divided by 2 pi r, 2 pi d. Okay, and now the thing is, we'll do ILB, okay, and then we'll get the force acting on the second wire. But I'm not getting into the derivations here. This is the formula that we'll be using, okay. And the main important idea that you need to keep in mind is that if we have parallel currents, then these wires attract each other, and if we have anti-parallel currents, then the wires repel each other. So parallel currents, parallel attract, an anti-parallel ripple. Okay, so now we'll look at the Q wire. So if we ignore R for now and just look at P and Q, so P and Q are anti-parallel. Anti-parallel wires will repel each other. Okay, so because of P, the force, if I say it is 1 on Q, it will be towards the right because they repel each other, and this force we will say it is F1. Okay, F1, if I want to write per unit length of Q, it will be mu naught I1 I2, which is 3, right, mu naught I1 I2 divided by 2 pi into D. D is 3 centimeters. Okay, so this is the force per unit length of wire Q just because of wire P. Now if I now look at Q and R, in this case these two are parallel currents. Parallel currents will attract each other. So this wire R will attract Q wire towards the right with some force F2. Okay, and this F2 divided by L similarly will be mu naught I1 I2, which is mu naught into 1 into 2 divided by 2 pi times the distance between them, which is 2 centimeters. Alright, so now because the two forces are in the same direction, the net force will be the sum of these two, right? So F1 plus F2 divided by L. So over here, if I take mu naught by 2 pi common, we'll have, so this 3 cancels out and this 2 cancels out. So basically 100 plus 100, which is 200, right? Now this was force per unit length. We wanted the force on 15 centimeters of length. So instead of L, we'll substitute 15 centimeters and we'll get the net force, which will be 15 into 10 to the power minus 2, converting centimeters to meters, multiplied by 200. Mu naught by 2 pi would be 2 into 10 to the power minus 7. Okay, so this cancels out with this. 4 into 15 will give us 60 into 10 to the power minus 7 Newton. So this will be 6 times 10 to the power minus 6 and the direction will be towards R, right? So option D will be the answer for this particular question. So the main idea is parallel currents attract, anti-parallel currents repel, and this particular formula of force per unit length. Okay, Sagnik, I'll do that. So yeah, this question it would be D, and for here it will be B option. And yeah, I guess the others we marked, right? All right, so let's move on. So now we have two wires whose materials are different and their lengths are 6 and 5.4 centimeters. The area of cross sections are also given. They are stretched by the same magnitude, okay, which means delta L is the same for both the wires and under the same load. So load essentially means the force, right? The force extending these materials. This is also the same. Then the question is the ratio of the Young's modulus of A to B is given to be x is to 3. Okay, so yeah, now we can just solve for what they asked for. So that is Young's modulus of A divided by Young's modulus of B. So Young's modulus is the ratio of the stress over strain. Is it 14? So which one are we talking about? This is 4.2. Oh, I guess you're asking about this one. So I guess it is 1.4 maybe. 0.4 plus 1, 1.4 I guess. Okay, so yeah. Alright, so moving on. Yeah, so the Young's modulus ratio would be the stress by strain, right? So the stress acting on, let's say this is basically cylindrical rods, okay? So the stress would be the force is the same, so I'm using the symbol A, divided by the area of cross section A. Then we have to divide it with the strain acting on the rod A, okay? So that will be delta L divided by LA. So LA goes to the numerator. So this is the YA of, this is the YA, FLA divided by, okay, this will be AA, area of cross section of A, into delta L. And for YB, it will be FLB divided by, and that thing goes to the numerator, area of cross section of B times delta L. Okay, so yeah, so this is it. So the F and delta L ones are the same. So LA divided by AA times AB divided by LB. So that is it. LA by LB, so the length ratio, LA by LB is 6 divided by 5.4, and AB divided by AA, that is 4.5 divided by 3. So this would become 2 and this 2.7. So this should be 5 divided by 3. Okay. Shashank, these are PYQs only. These are mainly PYQs from 2026 Jan attempt. Okay. So yeah, this is 5:3, so X would be 5. So yeah, so this is another rotation problem. So here we have two discs and radiuses are the same, 10 centimeter. They're joined at their centers by a rod of length 30 centimeters, okay, and mass 600 grams as shown in the figure. So the side view of the situation will look something like this. So this is the rod and the disc attached to the left end will be in this plane, and the disc attached to the right end will be in this plane. This is how the situation will look like, and the axis will be at 10 centimeters from the right one, something like this. Okay, so this is the situation. So instead what we'll do is, the radius is 10, so this length of the rod we'll take it as, radius we'll just take it as R for now rather than substituting everything. So the radius of the disc is R, this distance is also R, and this distance we'll take it as 2R. Similarly, the radius of the other disc is also R. Alright, so now the mass of everything is the same, 600 grams. It's mentioned that the torque of 43 times 10 to the power 5 dyne centimeter. So everything is in CGS units is applied. So we apply a torque about this axis. So we apply a torque about this axis, which means there will be an angular acceleration about this axis. That is what we have to find. Okay, so the alpha is what we have to find. Okay, so let's begin. So alpha is nothing but, for fixed axis rotation, it's straightforward. It's the external torque that we apply divided by the moment of inertia about the axis, right? So the torque is known to us, it's in CGS units. We'll just have to find the I about the axis, and then we'll just have to divide it, okay? So let's do it. We don't have to convert units because in CGS also the times unit is second only. So we don't have to convert any units, okay? So basically this question is to find the moment of inertia about this axis, okay? So let's first find the moment of inertia of this purple rod. That is much more easier. So the center of mass axis is something like this over here. So if this total distance is 3r, then this distance is 1.5r, okay? So if we subtract r from that, this distance turns out to be 0.5r. Okay, so now for the purple rod, we can find the moment of inertia about this axis O, this vertical axis I meant. So about this axis, the moment of inertia is going to be ml square by 12. So I about O, just for the purple rod, it will be ICM ml square by Okay, so here a length of the rod is 3r, right? So m into 3r squared, ml square by 12. And then we have to add m into 0.5r, which is r by 2 whole squared. So plus m into r square divided by 4. So this is a 4 cancels out with 12, so this is mr square by 3. No, this is going to be 9 by 12, okay, which is 3 by 4. 3 by 4 plus 1 by 4 is 1, so this will be mr square. So this is for the purple rod, okay. Now we have to find for the two discs. So for them we'll have to once again use parallel axis theorem. So for this disc, about this axis, which is basically passing through the diameter, you could say. So for a disc, whenever we have an axis which is the diameter of the disc, the moment of inertia is actually mr square by 4, right? For an axis perpendicular to the plane of the ring, it is mr square by 2. For an axis along the diameter, it is mr square by 4. So this axis, along this axis, the moment of inertia is mr square by 4. Similarly, for this disc also, the moment of inertia is mr square by 4. So let's write it for this disc first. So we have the mr square by 4, which is the diametrical axis 1, plus m into d squared. So what is the distance between the axis and the center of mass of the disc? This distance is r, right? So plus mr square. This is the moment of inertia of this yellow disc about the point O, or about the axis, this axis. Now for the other disc, it will be the mr square by 4 term plus, but here the d distance is 2r, right? So m into 2r squared, which will be 4mr square. So this is for the second disc, okay, which is the one on the right, and this is for the first disc. Okay, so now we'll just add them. So mr square, 4mr square is 5, 5 plus 1 is 6. So 6mr square plus, these two will add up to be mr square by 2, which is 0.5 mr square. So we have 6.5 mr square to be the total moment of inertia. Torque is 43 into 10 to the power 5. 43 into 10 to the power 5. I'm not modifying the units because everything we'll just keep it in CGS units. And then we'll divide it with moment of inertia, which is 6.5 mr square. So 6.5. Mass was 600 grams. R was, we took R to be 10 centimeters. So it will be 100. Okay, so if everything is correct, this should be it. So this should be the torque divided by 6.5 mr square. Okay, so this cancels out and this becomes a 10. So 430 divided by 6.5 into 6, so 360 and 30, so 390, 39, okay. So this becomes somewhat like 11ish, and yeah, that would be the answer, second option, okay. So yeah, this was mainly a moment of inertia calculation question, which is the simple ICM plus MD square formula, right? So that keeps appearing in a lot of JEE 2026 problems, which is a very important formula, the parallel axis theorem formula. So yeah, that is it for this question. So let's move on. Okay, so here we have the cell arrangement problem. So we have two identical cells, two identical batteries. EMF are given, EMF and internal resistance are given. So in case 1, the external resistance is 6 ohm. In case 1, they are connected in series, the cells are connected in series, and in case 2, they are connected in parallel, okay. In both situations, the current is the same, the current through the external resistance is the same. So the first situation is something like this. EMF. The two batteries are arranged in series. This is the external resistance, which is the 6 ohm one. And as they are in series, the equivalent internal resistance, we can write it as 2R, right? Now, the thing is, it's a matter of applying KVL, right? So, the equivalent EMF will become 2E because the cells are in series. So, the current will be 2E divided by 6 ohm plus 2R because they are in series, right? So, 6 plus 2R. This is the current in the first situation when both the cells are connected in series, okay? Now, in the second situation, both cells are connected in parallel. So, R, this is EMF E, like this, okay? And the external resistance is over here, 6 ohms. So, in this situation, the batteries, when they are connected in parallel and they have the same EMF, the equivalent battery that will be formed will also have the same EMF and two resistances are in parallel will give us R by 2, okay. So, this is the equivalent battery for this system over here, and then we have the external resistance of 6 ohms. So, the equivalent of this circuit is this particular circuit, okay. So, now once again, if you use Ohm's law, the current will turn out to be EMF E divided by R by 2 plus 6, okay. So, the statement mentioned to us, these two currents are equal, okay. So, now we can just solve it. So, cross multiplying R plus 12 equals 6 plus 2R. So, we get R equals 6 ohms. So, this is the internal resistance, okay. So, C option would be the answer for this particular case, alright. So, yeah, let's move on now. Okay, so this question is from thermodynamics, or you could say calorimetry. So, what is given to us is temperature versus heat graphs, okay. So, we are providing heat along the x-axis and on y-axis we are measuring the temperature for water, okay. And the temperature range is from -20 to +120 degrees Celsius. So, on the y-axis we have plots starting from -20 and ending at 120. So, then we have to say which of the graphs are correct for water. Okay, so let's solve this first. Okay, so the first part is we start from -20. So, at -20 degrees Celsius or any temperature below 0 degree, right? So, from -20 to 0 degrees Celsius, water exists as ice. Okay, so there is no other phase over there. So, from -20 to 0, when we go from -20 degrees Celsius to 0 degrees Celsius, what will happen is that the temperature will slightly increase for the ice. So, the more heat we give, the higher the temperature will rise. So, like in this particular graph, as you can see, until 0 degrees Celsius, the temperature steadily increases as we supply heat, okay. And if you observe at 0 degrees Celsius, there is a horizontal line, okay. So, this is the catch. What does the horizontal line mean? Horizontal line means there is no change in temperature, no change in temperature T, okay. And that is true. Why? Because there is a phase change happening. When the temperature hits 0 degrees Celsius, it's 0 degrees Celsius ice, right? And then when we provide extra heat, because of the latent heat of fusion that we are providing, the ice gets converted into water. But during that phase change process, the temperature remains constant. The temperature is still 0 degrees Celsius. So, this horizontal line that you are seeing, it represents a phase change process. Now, we know for water, there is a phase change occurring at 0 degrees Celsius, where there is a change between ice and water, and there is also a phase change happening at 100 degrees Celsius, right, where there is interconversion between water and steam. And during this phase change process, the graph must be a horizontal graph, right. So D option is wrong because they are showing another phase change at some temperature between 0 and 100. No, that is not the case. C, in the second option, there is a phase change at 0 happening and there is a phase change at 100 happening. Okay, there is no other phase change. At other locations, the temperature rises, right? Over here, it's basically heating up water. So the more heat we give, the temperature of water increases. Over here, the more heat we give, the temperature of ice increases. And over here, the temperature of steam increases. But at 0 and at 100, because of the phase change, there is going to be a horizontal curve. So this is the answer. Second option for this particular case for water. Okay. So yeah, that is it for this question. It tests you on, can you read the graph where phase changes are happening or not. Okay. So that's what was being tested on this question. Alright, so moving on. So here we have a diode problem. So assuming in forward bias condition, there is a voltage drop of 0.7 volt. Okay, so if you have some diode over here and if it is in forward bias condition, there will be a potential drop of 0.7 volt while we move across the diode. So that is what is being mentioned here across a silicon diode. They are asking what is the current through the diode D1 in the circuit. Okay, all the diodes are in the given circuit are identical. So all three are the same silicon diode. Okay, so if you observe over here, we have a ground condition given. So this particular point is grounded, which means all these three locations, you can consider it as a zero potential point. Okay, because of this grounding. Now, because of the battery, all these 3 points clearly will be at potentials greater than 0. So we'll just say it is equal to some V. So it's clearly greater than 0. Okay. So now when it comes to a diode problem, we have to check if it is in forward bias or reverse bias. Okay. And if it is in reverse bias, then there won't be a current through that diode. So these potentials are greater than 0. Okay. So this particular diode is forward biased. Okay. And the way to check it is if you observe this arrowhead and this particular line, the arrowhead should be at a greater potential. So over here, the triangle or the arrowhead, it is attached to the greater potential, right? Which means this is forward biased. So in this situation, it is forward biased. Okay, which means there will be a current flow through this diode, whereas the middle one over here, this is actually reverse biased. So this, through this branch, there won't be any current flowing. Okay, reverse bias just deletes the current flow through that particular circuit. Similarly, D3 is also in forward bias. So D1 and D3, D1 and D3 are forward biased. Okay, so there will be a current flow through either of them. So now the thing is, we'll just have to apply KVL. So we'll just say that total current through this branch is some I. Now because these two branches are identical, this I will split as I by 2, right? There won't be any current in the middle branch. So now we'll just apply KVL in this loop. So a rise in potential of 12 volt across the battery. Then as we move across the resistor, there is a potential drop of IR. So the current, let's say it is I. Resistance is 0.3 kilo ohm. So we'll just set it as 0.3 itself. And as we move across the diode terminal, there is a potential drop of 0.7 volt. So minus 0.7 volt is equal to 0. Okay, so from here, I turns out to be 11.3 divided by 0.3. Okay, so this is 113 divided by 3. Okay, so this turns out to be like 37 point something. So this current will turn out to be 37 point something. And make sure the current through the diode D1 is actually half of it, I by 2. So 37, if you do that calculation, the answer will turn out to be D option. Okay, so this will be some 37, 38ish. If you divide by 2, you'll get the D option. Okay, so that is it. So in the diode problems, main idea is we have to check if it is forward biased or reverse biased. 40-45 days, advance could be cleared with a good rank when one had studied and solved advanced questions in 2 years journey. Yeah, if you have solved advanced problems, then I would say, yeah, going through PYQ is sufficient, definitely. And yeah, you can get a good rank, definitely. But it also depends on that, what happens during that day, because JEE Advanced, like if you get one question wrong, right, your rank can go really down, especially when you are like up at the higher mark range, right? So it also kind of depends on luck, but yeah, but definitely if you solve PYQs and if you have solved good problems in the 2-year journey, you can definitely get a good rank. Yeah, 40-45 days are good enough. Yes, but yeah, you have to start soon, I would say. Shashank. So yeah, that is it. Okay, so this question was basically a simple diode problem. Okay, so this text is a bit small, but I'll read it. So basically we have a mass that falls from rest through a resistive medium. Okay, so this falls from rest should be removed. It falls with some initial velocity, take it as u. Okay, I'll explain why. So it falls through a medium having a resistive force of minus kV. Okay, where v is the velocity of the particle and k is a constant. So then the question is, which of the following graphs represent velocity versus time? Okay, so we have to find the velocity versus time graph, and the force is minus kV. Okay, so the particle, it is simply falling with some velocity v. Then the force is minus kV. Okay, the force minus just means it's opposite to the movement direction. So the force will be in this direction. Okay, so if I have the force, I can calculate the deceleration. It will be minus kV by m, right? So now my main goal is to find the velocity function as a function of time. So I'll write the acceleration as time derivative of velocity, dv by dt, right? So now we'll solve this function. dv divided by v equals minus k by m times dt. Okay, and then we'll integrate it. So at t equal to 0, we'll say the initial velocity was some u. At t equal to t, the velocity, let's say it is v. So this integral becomes a log integral, right? So ln of v by u, right side is simply minus k by m into t. So from here, v turns out to be u e to the power minus k by m into t. So this is the exponential decay graph, right? So we start from, so if I have to plot a rough sketch, if the initial velocity is some u, it exponentially decays. This is going to be the graph of v versus t, the exponentially decaying graph. Okay, so that will be option D. Now the thing is, if the reason why the falls with some rest should be discarded is because if it is at rest, then the force is also 0. So if the initial velocity is 0, then the force is also 0. And if velocity and acceleration are both 0, then the particle does not move, right? So in that case, the velocity time graph will be just 0, basically. There is no motion. Okay, so that is it for this question. It's a integral question, right? Okay, so this question is good. So we have been given a PV graph. Okay, so pressure versus volume graph of a gas, the equation of state. Okay, and the graph is a parabolic graph. This is the x square is equal to 4ay graph, right? So this is the equation of a vertical parabola, something like that. Now the question is, what is the total work done in this closed path? So this is the path, B to C, C to A, and A to B, this path. So we have to find the work done in that closed path. Okay. All right. So yeah, so the first thing that you should like directly just by looking at the graph, you should be able to tell that the net work done in this path by the gas, it will be negative. Okay, because this process CA over here, it is a compression process. If you observe, we go from higher volume to smaller volume. So the process C to A, it is a compression process. Okay, and because of that, this guy's work done will be the largest in magnitude. And compression work, we know that when a gas is getting compressed, the work done by the gas is negative. So the work is negative. So basically the simple trick to understand if the net work will be positive or negative is if it is in the counterclockwise sense or not. So if the closed process is like this, if in this case it is counterclockwise in nature, the net work done, the net work will be negative. Okay, and if it was clockwise, then the net work will be positive. Okay. All right. So that's the first idea. So the net work done is going to be negative. So the positive options are just wrong. Okay. So now the thing is moving on to the magnitude. So the magnitude, as most of you may just be knowing, whenever we have a closed process like this, the net work done is simply this area, right? Like whatever the process curve may be, like most of you may have studied the circular one, right? Circular process. And in this case, the work done is simply the area of this circle. Or similarly, there was other problems in which we had a right triangle, right, for the graph. In that case, the net work done will be the area of the right triangle. So, alright, so now basically the question is to calculate this area, which is a math problem, right? The area under the curve chapter exercise. So for this, I am just going to use a trick. I am just going to state it over here. And that is, whenever we have a parabola, we can sandwich it inside a triangle, something like this, right? So we can draw the parabola something like this. So you can imagine this is like the y equal to x square type of a parabola. And we can sandwich it in between these two, this rectangle basically. Now let's say this height is some h, okay, and the base is some a. So this trick you must have covered in maths while covering area under the curve. This particular area, if you want, which is the area between the parabola and like this y equal to h line, if you want that area, this is in fact 2/3 of the area of the rectangle. Okay, so whatever this rectangle is, if you want this particular area between the parabola and the y equal to h line, then the answer is 2/3 of area of the rectangle. Okay, and if you want the other one, it's 1/3 of the area of the rectangle. Okay, so we are going to be using this to calculate the area here. Okay, so what is the base? So the rectangle is already drawn for us, if you observe. So the base length of this rectangle is 2 meter cube, right? All we have to do is find out this height. Okay, so the equation of the parabola is given to us. So height is nothing but the y coordinate of this point C. The point C has an x coordinate of C, right? X coordinate is simply the volume. So instead of volume, we'll put 3. So if I do that, 3 minus 2 is 1. So 1 equals 4 AP. So from here, the pressure at this location, which is basically the height, right? Pressure at C, that is also the height of this rectangle. So pressure at C, we get it as 1 by 4A. Okay, so this is a rectangle whose height is 1 by 4A and base is 2 meter cube. So the area, the work done is actually this area, right, between the parabola and this line AC, as you can see. And that we discussed here, it is 2/3 the area of the rectangle. So the work done, we have to include the negative sign. Base is 2, height is 1/4a, and we have to include this 2/3. So 2/3 times base is 2 meter cube, height is 1/4a, and the answer will be, so this 2 cancels out with 4, and the final answer is minus 1/3a. Okay, so that will be option A. So for parabolas we can use this rectangle trick to answer it. Okay, so that is it. So yeah, let's move on. Okay, so this is a simple formula based problem. So the we have a current carrying disk, okay, and we have to find the magnetic field at some point on the axis. So this particular formula. So it's given that the magnetic field at the center of a loop is 16 mu Tesla. Okay, so this is micro mu Tesla. So when we have a current carrying circular loop, the magnetic field at the center, right? The magnetic field at the center, this formula is mu naught I divided by 2R, right? And mu naught I divided by 2R. This is given to be 16 mu Tesla. Okay, and then the question is, we need the magnetic field at x equal to root 3R. So this distance is root 3R. This is of course R. And we need the magnetic field due to this wire at this location. So this formula we cover it in classroom. So the formula for that field is mu naught IR square upon twice of R square plus X square raised to the power 3/2. Okay, so here it will be mu naught I R square divided by twice of, so X is root 3R, so this will become 3R plus R, which is 4R square. Okay, so this thing will become 4R square. If you take the root, it will be 2R. If you cube it, it will be 8R cube. So over here we'll have 8R cube. So R square cancels out with this. So this is mu naught I by 16R. Okay, so this is actually 1/8 times of this value, right? So 16/8 will become 2 mu Tesla. Alright, so the answer is 2 for this. Okay, so that is it for this question. Simple formula based problem. Okay, so now we have an NLM problem. So we have a mass moving on an inclined plane, makes an angle of 30 degrees with the horizontal. Friction between the inclined plane and the block is given, coefficient of friction. We need to find the force that we need to apply so that the block will move down without acceleration. Okay, so inclined plane makes an angle 30 with the horizontal. So we have a block something like this. Now it's mentioned that the block needs to move downwards. Okay, so the motion or the velocity of the block is downhill. That is sure. And it moves without acceleration. Zero acceleration. This just implies F net is 0. There's no net force along the inclined plane. So, downhill we have mg sin theta force. We don't have to care about the normal direction forces. So we have mg sin theta downhill. Now because the block is moving downhill, meaning the velocity is downhill, the friction will be in the uphill direction, right? So the force of kinetic friction, which is mu mg cos theta, it will be uphill. We can say that because the block is moving downwards, right? So now the thing is, the question is, we have to apply some force. How much is that force for the net force to be 0? So first let's find out the magnitude of mg sin theta. So mass is 5, g we'll take it as 10, theta is 30 degree, right? So this will become 50 into sin 30, this is 25 Newton. Mg sin 30 is 25 Newton. So over here mg cos theta will be 25 root 3. If I multiply this with mu, which is root 3 by 2, it will become 75 by 2, which is 37.5 Newton. Okay, so clearly friction force is larger than the mg sin theta force. So we'll have to apply the F force downhill. This is the force that we have to apply to support this 25 to balance out the 37.5 Newton. So 25 plus what is 37.5? 12.5. So 12.5 is the force that we have to apply in the downhill direction if I want to balance the, if I want to make the net force on the block 0. Okay, so that is this question. All right. Okay, so yeah, we have 2 point charges, 1 nanocoulomb and 2 nanocoulomb. They are placed at the corners of an equilateral triangle whose side is 3 centimeters. Okay, so we have an equilateral triangle and we have 2 point charges, 1 nanocoulomb and 2 nanocoulomb. Okay, they're placed at the 2 corners of this triangle. The question is, what is the work done in bringing a 3 nanocoulomb charge from infinity? So from infinity we are bringing a 3 nanocoulomb charge and placing it at the other vertex. Okay, so what is the work done? So the work done's formula is pretty simple. So the work done will be delta U, the change in electrostatic potential energy of this system. Okay, so let's say this is charge 1 Q1, this is charge 2 Q2, and the other one is charge Q3. So this is simply UF minus UI. So when the 3 nanocoulomb charge is placed at the other vertex, we'll have to count the interaction of 1 and 3, 1 and 2 and 2 and 3, right, to write the total final potential energy. So UF would be K Q1 Q2 by R, so this distance we'll take it as A. Okay, so if instead I say this is Q, this is 2Q, and we'll take this as 3Q. Okay, so the interaction of these two will be KQ times 2Q divided by A, so that will be 2KQ square by A, and interaction of these two will be 3KQ square by A, and interaction of these two will be 6KQ square by A. Okay, so this is the 3 interactions, mutual interactions between the charges, and initially only these two existed, so we have to subtract 2KQ square by A, right? So this cancels out with this, and the final answer is 9 KQ square by A. So the work external agent does is 9 KQ square by A. Okay, so now it's just calculations. So you can substitute K as 9 into 10 power 9. Q is known, 1 nanocoulomb. A is going to be 3 centimeters. Okay, so we can ignore the calculations. All right, so yeah, that is it for this question. Alright, so now we have a convex lens whose refractive index is 1.5 and focal length is 18 centimeters. Okay, it is immersed in water. Now the question is, of course, when we immerse a biconvex lens into water, the focal length changes, right? So that change in focal length is what they're asking. So while we dip it into water. So this is a standard lens maker formula question. So for a normal biconvex lens, okay, which is placed in air basically, if the refractive index of this is mu, if I apply the lens maker equation here, then we'll say 1 by the focal length equals the refractive index, let's take the symbol n, so n minus 1 times 2 by r if both the radii of curvatures are equal. This is a lens maker's equation applied to this case where the lens is placed in vacuum. Now if when we place it in water in the second situation, okay, so let's say this is NW. In this situation, this formula modifies a bit and the focal length will change. We'll call it as f dash. And instead of the n term, it will be n relative. Okay, so that is n divided by NW. So this term becomes n over NW minus 1. And the radii of curvature 1 just remains as such, 2 by r. So this is the difference in lens maker formula when we change the medium in which the lens is placed. Okay, so now because we only need the change in focal length, we'll just divide these two equations. So that gets rid of the 2 by r, right? So f dash divided by f, this will be equal to n minus 1 divided by n by NW minus 1. Okay, so now these values we know, so we'll substitute. So n minus 1 will be 0.5 and n divided by NW, so 3 by 2 divided by NW is 4 by 3, 4 by 3, so 9 by 8. 9 by 8 minus 1 would be 1 by 8. 8 times 0.5 is 4. Okay, so the new focal length f dash is actually 4 times the original focal length. Okay, so now the question they asked is, what is the difference in focal length of the given lens when it is in air and water? So when it is in water, it is 4f. When it is in air, it is f. So the change delta f is 4f minus f, which is actually 3f. Okay, so this is what they're asking, the factor 3. Okay, so that is the question for, that is the answer for this question. All right, so I hope that is clear. So yeah. All right, so now we have a solid sphere whose radius is 10 centimeter and it is rotating about an axis which is at a distance of 15 centimeters from the center. Okay, situation is something like this. So we have the axis like this and the sphere is over here. The center of the sphere is at a distance of 15 centimeters from this axis and the radius of the sphere is given to be 10 centimeters. So whenever a radius of gyration problem is asked, the first step should be to find the moment of inertia of the system. Okay, so if this particular system is rotated, we'll use once again parallel axis theorem. So we know the moment of inertia about this axis, right? This is the axis passing through the center of mass, ICM. So for a solid sphere, ICM is 2 by 5 mr squared, right? So that is the moment of inertia about this axis. We'll have to add m into d squared if I want the moment of inertia about this axis. Let's call this axis as IA. So IA will be 2 by 5 mr square plus m times 15 square. So we can just substitute. So the radius is 10. So 10 square will become 100 and m into 15 squared. So m into 225. This is the parallel axis theorem applied to this system. So this will be, so pi cancels out. So 40 plus 225 is 265 m. Okay. This is the moment of inertia about this axis IA. Okay. Now the thing is, the idea of radius of gyration is that if I want to replace this whole system, this sphere system, with a point mass at some distance, okay, this point mass which has the same mass as this sphere, and if I have to replace it with a point mass, and this point mass is at some distance from the axis, let's say x, okay, then this is called the radius of gyration. Okay, so the radius of gyration is that distance at which we place a point mass so that the moment of inertia of this system, the point mass system, and the moment of inertia of this system, they become identical. Okay, so basically this moment of inertia which we calculated, this should be equal to m times x squared, because the moment of inertia of a particle is simply mass multiplied by distance from the axis squared, right? Now this x is our radius of gyration. So now we cancel these two, and the value of x turns out to be square root of 265. This is our radius of gyration. Okay. So the value of n will be 265 in this question. Okay, so that is radius of gyration problem. Yeah, so let's move on. Okay, so this question is a simple question. So we have a particle executing SHM. So the sine function is given a sine omega t. Everybody knows what this is. It's a simple sinusoidal SHM. So you can think of spring mass as well. Okay, and this is the x equal to 0 position, and how the position varies with time is given to us by the sine function a sine omega t. So at t equal to 0 it's at mean, at t equal to t by 4 it is at the extreme position, which is at amplitude, right? And at t equal to t by 4, after t by 2 it comes back, t by 4 goes back, and after t it comes back to the origin. So this is the standard SHM. Okay. Now the question is, if the maximum value of the potential energy of the oscillator, so max value of the potential energy of the oscillator, so that happens, you could say, at t by 4, right? So at t by 4 the particle or the mass reaches the extreme position, right? And when it reaches the extreme position, the spring is maximally compressed or elongated. So it happens at t by 4, so we can say beta value is actually 2, right? So it's t by 2 beta. So when is the spring maximally elongated? At t by 4, so beta will be 2. Okay, so the value of beta is 2. All right. So yeah, that is basically it. So max potential energy, you can think of the potential energy of the spring. So it is maximum when the compression or the elongation in the spring is maximum. Okay, so that is it. All right, so now we solve this question. So the equivalent resistance between point A and B in this circuit is what we are asked. So try out this problem, guys. Yes, Alex, it would be 265, yes. Okay, so this circuit, the interesting idea here is that it's not a Wheatstone, right? So that's the first thing that you need to confirm. 6 by 3 is 2, 3 by 6 is half. This is not a Wheatstone bridge. Okay, so now this particular circuit where we have 6 3 up top, right, and a bridge in the middle, and then we have 3 6 in the bottom one. This circuit has a special symmetry to it. Okay, and this we cover in class. But the simple logic behind this circuit is that if I assume a current I1 in this 6 ohm resistor, then the current in this 6 ohm resistor will also be I1. Okay, so and we prove this using some symmetry topics, which, you know, if I cover it here, it will take us like 10-15 minutes. So, and similarly, if the current in this 3 ohm resistance is I2, by symmetry it will be I2 in this branch as well. So there is kind of like a current symmetry between the resistors. So in this 6 there is I1, then in this 6 also it is I1, and in this 3 it is I2, and in this 3 also it is I2. Okay, and this is only true for this type of a circuit where we have like 6 and 3 above. So R1 and R2 and R2 and R1. Those type of circuits, if you get, then you can apply this logic. So entering current I1, exiting current is also I1 on the same resistor, and similarly over here also. Okay, so the thing is, if you know this, then it's a matter of solving two equations if you want the equivalent resistance across RAB. Okay, so let's do that. So basically, if the current here is I1, if I want to replace it with an equivalent circuit, what is the total current entering the node A? So on this branch the current is I1, and on this branch the current is I2. So the total current entering is I1 plus I2. Right? The total current entering is I1 plus I2. Similarly, the total current leaving is also I1 plus I2. Okay. So if I want to draw an equivalent circuit, it will be, we'll have the nodes A and B, and in between we'll have an R equivalent. Okay, and the current in this branch will be I1 plus I2. Okay, this will be the equivalent circuit for this particular circuit, and it's this R equivalent that we have to find. Okay, so in this circuit, if I use simple Ohm's law, right, then I can say VA minus VB or VAB is equal to I1 plus I2 IR basically. So I1 plus I2 into R equivalent. So now what we'll do is we'll try to find I1 and I2, or basically what is VAB in this circuit using KVL, and try to compare it with this equation. That way we can get RAB or R equivalent. Okay, so let's do that. So what are the two branches? So we have we can take this particular loop to write VAB. Okay, so VA minus I1 into 6 minus I2 into 3 equals VB, which means VAB equals 6I1 plus 3I2. Okay, so 6I1 plus 3I2. This is the first KVL equation in which we took this branch. Okay, the second equation we can take this branch. So here the current is I2, here the current is I1. So we can use KCL in this node. Entering current is I1, exiting current is I2. So the current in this side, in the down direction, is I1 minus I2. Okay, simple KCL. So now we can use KVL in this loop over here. So minus 6I1. So minus 6I1 potential drop minus 3 times I1 minus I2 and a plus 3I2 is equal to 0. Okay, so this is the second KVL equation. So minus 3 minus 6 is minus 9. Take it to the other side, it will become 9I1. Here we have 3I2 plus 3I2, 6I2. Okay, so I2 is, or I should say 3I1 equals 2I2. Okay, so this is another relation. Okay, so now we can put I2, so 3I1 is 2I2, so 6I1 is 4I2. So 4 plus 3 is 7I2. So from here we get I2 as VAB divided by 7. VAB divided by 7. and I1 is 2 by 3 I2. So this will become 2 VAB divided by 21. So let's confirm again, 6 I1 would be double this, so which is 4 I2, 4 plus 3 is 7 I2, okay. From here I2 is VAB divided by 7, and also I2 is 3 by 2 I1, or I1 is 2 by 3 I2. So 2 by 3 times this value is 2 by 21 VAB. So now we have I1 and I2. That we can substitute over here. So VAB equals I1 is 2 by 21 VAB, 2 by 21 VAB (2 by 21 VAB and VAB by 7). Plus VAB by 7. This multiplied with R equivalent. So from here now we can get R equivalent. So we can cancel out these 3. So multiplied with 3. Here also multiplied with 3. So 3 plus 2 is 5 by 21. So R equivalent, if I have not made calculation mistakes, it should be 21 divided by 5. 2 by 21 and 3 by 21, 5 by 21, yeah. So it should be 21 by 5 ohms. Okay, so the main idea is the current symmetry. So I1 entering, I1 leaving. On the 6 ohms it's the same, and on the 3 ohms also it's the same current. Then we write down 2 KVL equations. After doing that, we find I1 and I2 in terms of VAB, and then we convert it into the simple R equivalent diagram. So across the nodes A and B, we plug in an R equivalent instead of this whole circuit, and through this R equivalent the total current is I1 plus I2, right? Because the I1 plus I2 current is entering here as well. After that, here we apply simple Ohm's law. VAB equals I into R, and then we take this I1 and I2 and put it here. So that is the logic that we did. You can also use a nodal method. You can also use star delta. Okay, so there are different methods here, but yeah, this is just one of them, one of the methods. All right, so yeah, that is it for this question. Okay, so now we have the time period of a simple harmonic oscillator. This is given to be 2 pi square root k by m. The measured value of mass of the object is 10 gram. So the mass of the object is 10 grams with an accuracy. So instead of accuracy, just include uncertainty, okay, or error, basically error of 10 mg. So 10 grams plus or minus. So this will be 10 mg. Okay. Now the time for 50 oscillations of the spring is found to be 60 seconds using a watch of 2-second resolution. So the time period of one oscillation, this is going to be 60 divided by 50, right? 50 oscillations took 60 seconds. So one oscillations take 60 by 50, which will be 1.2 seconds. So 1.2 second plus or minus the error possibility of the watch is 2 seconds. So okay, I think it should be something else rather than 2 second, because 2 second is a large error. Anyway, I'll discuss the logic here. So the logic is we have to, of course, find the percentage error in the spring constant. Okay, so the main, the objective is to convert that relation so that the spring constant comes on one side. So basically we'll have a t square we'll square this, some constant k by m. So k will become mt square times some constant, okay. So now we apply that simple formula, which is delta k by k equals delta m by m plus 2 delta t by t, okay. And with this we can get the total percentage error of the spring constant. But here I guess there is some issue with the error in the time in the question. So yeah, but the method is like this, of course. Then you basically multiply both sides with 100, okay. That way you can get the percentage error. So yeah, that is basically it. So this is the actual value of m. So instead of m you will put 10 grams. Instead of delta m you will put this 10 milligram. Delta t is the uncertainty in time. So this stopwatch error, I don't think it's 2 seconds, because 2 seconds is a large value for error. So this should be something else, but yeah. So over here in delta t, we substitute the error, okay, and t is the time for one oscillation, okay. So that is how calculation is done here. So now we can move on. All right, so now the thing is, we have a Wheatstone bridge that is initially at room temperature, and all arms of the bridge have same value of resistances, okay. So all the 4 resistances are the same. When R3 resistance is heated to some temperature, its resistance value goes up by 10%, okay. So the resistance of just the R3 resistance, this one, increases by 10%, okay. Then the question is, what is the new potential difference between points A and B? Between these 2 points, what are the new potential difference? Okay, that is the question. So we can draw a slightly different diagram. So this is a 40 volt battery. So situation looks like this. So we can assign this node a potential of, let's say, 40, and this node a potential of 0 volt. So then we have R2 and R4. Here we have R2 and R4. And on the other side we have R1 and R3. Okay, so this is the circuit. Okay, so R1, R2, R4 remain the same even after the heating, right? So instead of R2, R4 and R1, we can just write them as R. So these 3 resistances we can just call it as R. And R3 has increased by 10%. So if you increase 1 by 10%, it will become 1.1, right? So this becomes 1.1 R. This is the new value of resistance R3, okay? So now the question is, this is point A, this is my point A, VA, this is my point B, VB. We need the potential difference, okay? So let's say the current here is I1, the current here is I2. So the I1 into 2R is the potential, is the 40 minus 0, 40 volt, right? So I1 into 2R equals 40. Simple Ohm's law in this branch. And in this branch, the net resistance is 2.1 R and the current is I2. So this should also be equal to I2 into 2.1 R. Okay. So by symmetry, VA is nothing but 20 volt, right? Because these 2 resistances are identical. And over here, the current is I2. So this VB voltage minus 0 is I2 into R. So VB is going to be I2 into R, right? Using this branch, applying Ohm's law. I2 into 2.1 R is 40. So I2 into R will be 40 divided by 2.1. So this is 40 divided by 2.1. So we have VB and VA. Their difference VAB will be 40 by, this will be 20 minus 40 divided by 2.1, right? So this will become 42 minus 40, which is 2 divided by 2.1. Okay, so whatever this comes out to be, that is going to be the answer. So some 0.95 maybe, I guess. So that will be the answer to this question. Okay. Yeah, all the best, guys, whoever have today first shift. All the best to all of you. Just pick the easy questions first. I guess you guys know the tips and tricks, right? So yeah, all the best to all of you guys. So yeah, that is just, this question is pretty simple. It's just that this one resistance became 1.1 R. After that, it's Ohm's law. All right. So yeah, so now we have the speed of a longitudinal wave in a metallic bar is 400 meters per second. So this formula we discuss, the longitudinal wave speed on metallic bar. This is actually square root of the Young's modulus of the bar divided by the density of the material. Okay. Now the question is, both the density and the Young's modulus are increased by 0.5 and 1 respectively. Okay, so these are absolute values. Okay, so these are not absolute values, these are percentage values. Okay, so these must be percentage, 0.5% and 1%. Then the speed of the wave is changed approximately to. So what is a change in the speed? If we like increase the density by 0.5% and the Young's modulus by 1%. Okay. All right. So the thing is, because the percentage change is so small, it's just 0.5% and 1%. We can use that derivative formula, right? The same formula which we use to derive the error approximation formula, right? So we will differentiate and take the log. So what we'll get is dV by V equals, so in for the dy by y term there will be a half, right? So it will be half dy by y, and the rho is in the denominator, so there will be a minus half d rho divided by rho. Okay, so this is what we convert it into the error approximation formula, and in that formula we put a plus here. But if you actually do the math, which is basically taking logarithm on both sides and differentiating and actually calculating what is dV by V, this is the relation that you get, okay, without any error analysis approximation. In the error formula we put a plus sign here because we want the maximum error, right? That is possible. So, but the actual mathematical operation will give you this relation. So the reason for using this is because the percentage change in the density and Young's modulus is very, very tiny. It's just 0.5% and 1%. So what we need is the change in the speed. Okay, what we need is this dV. So this dV divided by the original speed, which is 400 meters per second, is equal to half the percentage change in the Young's modulus. So the Young's modulus is increased by 1%. So this will become 1 by 100, right? Minus d rho by rho. So the density increased by 0.5%. So this will become 1 by 50. No, 1 by, this will be 0.5. So it will be, let me check the calculations a bit. Okay, so yeah, it's fine. So 0.5 divided by 100. Okay, so the 100 cancels off. So on both sides the 100 cancels off. 1 minus half is just half. So half multiplied by half is 1 by 4. 1 by 4 on the right side and 1 by 4 on the left side. So dV just becomes 1 meters per second. Okay, so this is the small change in the velocity. So if dv is plus 1, that means the speed increased by 1 meters per second. So the original speed was 400, final is 1. So the new speed will become approximately 401 meters per second. Okay, so that is option D. Okay, and the reason for using this formula is because the percentage change was small. If it was large, then we cannot use this formula, right? And that is, you can just see it, right? So dV is a very small change. Similarly, D Young's modulus and D density, these are all small quantities. Okay, so yeah, that is it for this question. All right, so yeah, so this question is done. Okay, so next problem is we have a nucleus whose mass number is given alpha and radius r alpha. So this formula we have already explored earlier. Then we have a second nucleus whose mass number is beta and radius r beta. We have been given a relation between beta and alpha. Question is, what is the radius ratio? Okay, so this is a same formula that we saw earlier. So the radius of alpha over radius of beta is what we need, and the ratio is proportional to the mass number to the power 1 by 3, right? So this will be A alpha divided by A beta raised to the power of 1 by 3. Okay, A alpha divided by A beta. So the mass number is alpha and beta, right? So A alpha will be simply alpha divided by beta is 1 by 8. So 1 by 8 raised to the power 1 by 3 will be half. Okay, so the answer is going to be half, 0.5. All right, so yeah, this formula we already explored in the second or third question. Okay, so next problem is a mechanics problem. A block of mass slides from the top of a frictionless slope inclined surface, and the inclined plane is moving towards the left with an acceleration of a0. Okay, so the angle between the inclined plane and the ground is theta, and its base length is capital L. Okay, so this length is L, this angle is theta. Assume that initially the small block is at the top of the inclined plane. What is the time it takes to reach the lowest point of the inclined plane? Okay, so we want how much time it takes for this block to reach the bottom of this inclined plane. Now, because we only want to see how this block moved on the inclined plane, we can move into the frame of the inclined plane. Okay, so this inclined plane is actually moving to the left with an acceleration of a0. We can move into the frame of the inclined plane. Okay, so if I do that, then of course the inclined plane comes to rest, right? So let's redraw the diagram. So the inclined plane now comes to rest. This particle is over here. Okay, now we are working in the frame of inclined plane. Okay, so we have brought that to rest. It was initially moving with acceleration a0. Okay, now when we move into the frame of the inclined plane, because the inclined plane was accelerating, we have to apply a pseudo force. Okay, so blocks, the inclined plane's acceleration was a0 to the left, so pseudo force on this tiny block should be mass of the block times a0 to the right. Okay, and this pseudo force is being applied because we moved into the frame of the inclined plane. Other than that, everything remains same. The mg force, the normal force, which I am not drawing, there is no friction in the question. Now, because of this force, this block will start moving downwards. This acceleration, we'll call it as the relative acceleration. right? Because we are in the frame of the inclined plane. So now the goal is to find this relative acceleration, okay? And for that we can use F equal to ma. So mg's component along the incline is mg sine theta, and ma naught's horizontal component will be in this direction, and this is ma naught cos theta. Okay, so in the direction of the AR relative acceleration, the net force is mg sine theta minus ma naught cos theta. So we can say m into A relative is mg sine theta minus ma naught cos theta. Okay, so from here the relative acceleration is going to be g sine theta minus a naught cos theta. So this is the acceleration, the relative acceleration of the block if we are observing with the frame of the inclined plane. Okay, so now once we know the acceleration, it's just kinematics. So we know the acceleration of the block now, the relative acceleration. The relative distance the block has to cover is this distance. The base was given to be L and this angle is theta. So the hypotenuse will be L divided by cos theta, right? So the relative displacement that the block has to cover is L divided by cos theta. With that we can easily find the time, right? Initial velocity is 0. So L divided by cos theta equals half AR. AR was g sine theta minus a naught cos theta, half a t squared. This is the time it will take the block to go from top to bottom. Okay, so let's see. So that time will be 2L divided by g sine theta cos theta minus a cos square theta. So this will be g sine theta cos theta minus a naught cos square theta. Okay, and the under root of this thing. So this is the answer. Now in the options they are converting it into sine 2 theta cos 2 theta and stuff. So that is just trigonometry, we can do that. So what we'll do is we'll multiply and divide with 2. So this will become 4L, right? And here 2 sine theta cos theta will become sine 2 theta. So this is g sine 2 theta. And then we have 2 cos square theta. So 2 cos square theta is 1 plus cos 2 theta, right? So this becomes a naught 1 plus cos of 2 theta. Okay, and this whole thing in an under root. So this will be the answer if we convert theta to 2 theta terms. Alright, so 4L divided by g sine 2 theta. So this looks like the answer, option A. Okay, so alright. So first class, thank you so much, Mayank. Thank you so much. Manya, my bad. Alright. So yeah, everything is covered in this question. Duration, I guess there will be like 4 or 5 more questions. After that we'll be done. Okay, so let's move on. Okay, so now the question is, we have a number of photons of equal energy emitted per second. So photons of equal energy just means that the photons have the same wavelength or the same frequency, right? Because a photon's energy is given by h nu or hc by lambda. So yeah, so and the laser's energy, I mean the power rating is given, it is 6 milliwatts. Okay, so yeah, that is it. So now the question is, what is the number of photons emitted per second if the laser is 6 milliwatt? So we have some laser and it is emitting photons and the power of emission is 6 milliwatt, okay, which essentially means 6 millijoules of energy is being emitted. Okay, every second. So 6 millijoules is the energy emitted each second. So in 1 second, 6 millijoules of energy is released by this laser. Now, this energy is carried by the photons, right? The energy of an individual photon, we can write it as either hc by lambda or h nu. Here we are given the wavelength, so we'll use hc by lambda. Now let's say in that 1 second in which 6 millijoules of energy was released, it comprised of, let's say, n photons, okay? So this 6 millijoules, which was the energy released in 1 second, there were, let's say, n photons. Each photon had an energy of hc by lambda. Alright, so this is a simple energy balance equation. So yeah, now let's just substitute everything. So 6 times 10 to the power minus 3 equals the number of photons released times Planck's constant is 6.63 into 10 to the power minus 34. Speed of light is 3 into 10 to the power 8 divided by the wavelength 663 nanometer, which is 6.63 into 10 to the power minus 7, right? Nano is 10 to the power minus 9. So of the 663 I divided by 100, so I have to multiply by 100, so it becomes 10 to the power minus 7, okay? So this is the calculation. 6.63 goes, 3 cancels out with this 6, 7 and 8 becomes 15, 34 minus 15 would be 19, right? So that 19 coming over here, minus 3, so n would be 2 into 10 to the power 16. So this will be the number of photons emitted once in 1 second. So in 1 second, 6 millijoules of energy is released. 6 millijoules of energy equals energy of one photon times the number of photons, and that number of photons after solving comes out to be 2 times 10 to the power 16. Okay. Yeah, I will take more classes. I don't know when will be the next class. I'll surely inform you. So yeah, that was this question. Okay, so this is another kinematics problem. So we have a particle that starts from t equal to 0. Coordinate is given to us. X coordinate is given to us. So this is a one-dimensional motion. The first part is the particle returns to the original position 0.866 units later. So this is the time unit. So the first question is asking, when is the particle coming to the original position? So at t equal to 0, the particle was at the origin. So if this is the x-axis, this is the origin, this is where the particle is at t equal to 0, which is x equal to 0. Now, when does the particle come back to the origin? So how do we find that? When the particle's position, the particle's position is known to us. So we want it to come back to the origin. So we'll just set that equal to 0. So 4t cube minus 3t equals 0. So the first root of this equation will simply be t equal to 0, right? That is the initial instant. The second will be 4t square minus 3, and we'll set it equal to 0. So from here, t turns out to be root 3 by 2. This is 1.732 by 2. Once you solve it, it will come out to be this value approximately. Okay. So A is correct. So after this time, the particle comes back to the origin. Now, second option is the particle is 1 unit away from the origin at its turning point. Okay, so what does turning point mean? Turning point is the particle will start moving either towards the left or right. So let's say it starts moving towards the left. We can find out in which direction it moves. And at some point it comes to rest, and then it starts moving to the right. This point is what we call as the turning point. Okay. So what's the property behind this turning point? This is where the particle comes to rest. So it goes to left, comes to rest at this location, and the velocity starts moving along the x-axis. So negative velocity, 0, positive velocity. So it turns when the velocity becomes 0. So in order to find the velocity from the position, we'll just have to differentiate, right? So the velocity vector will be 12t square minus 3. So if you observe this function, like let's say if you put t equal to a very tiny value, I mean not even that, if you just look at the simple graph, it starts from negative, right? If you put t equal to 0, it's negative 3. So which means the particle's initial velocity when it's at the origin, it's towards the left, because the velocity at t equal to 0 is minus 3 meters per second. So it starts moving to the left. At some point it will come to rest, which is speed equals 0. After that point it start moving to the right. So that turning point we can find by setting v equal to 0. Okay, so the turning point for this, we'll set v equal to 0, which means t square equals 1 by 4, right? 12t square equals 3, t square equals 1 by 4. This means t equals half. So after half units of time, the particle comes to rest. Okay, this is when it comes, this is when it reaches the turning point. So the question is, where is that turning point? So it is somewhere over here. So we need to find its x coordinate. So for that we'll substitute this t equal to half into the x coordinate. Okay, so x will be 4 times half cube, which is 1 by 8, minus 3 into half. So this is half minus 1.5, which is minus 1. Okay, so the particle starts moving to the left. It moves to the left by 1 unit and comes to rest. So that is what is asked in the second option. The particle is 1 unit away from the origin when it reaches its turning point. So that is correct. So B option is also correct. Okay. Option 4, C option 2. Oh, okay, you're talking about this. So yeah, we'll see. A and B are correct. So I guess it should be B option. Right, it should be B, I guess. Now let's look at C option. Acceleration is non-negative. So that is very easy to check. For acceleration, we differentiate this function. So acceleration is going to be 24t. Now time is always positive, so acceleration is always a positive function. So C option is also correct. Acceleration is always non-negative. Okay. So A, B, C and correct are correct. So only B option matches. Okay, so the other two must be wrong. So you guys can check it out as homework. Okay. I mean, this is just clearly wrong because we proved that it's 1 unit away instead of half a unit. The particle never turns back. This is also not true, right? Because after t equal to half, it starts moving to the right. You can put values into the velocity expression to check that. If you put values less than t equal to half, velocity will turn out to be negative. Negative velocity means the particle travels along the minus x direction. If you put large values of t, let's say 10 seconds or something, velocity will be positive, meaning the particle travels along the plus x direction. So it definitely turns. It's initially moving to the left and it starts moving to the right. So E option is also wrong. Okay, so answer will be ABC. Okay, so B option is correct. So yeah, so this I guess is the last question of the day. The next question is like, I mean, it's just area of this right triangle, the total work done. So yeah, this is the final problem. So here we have a plain electromagnetic wave. Okay, it's moving in free space, which means the speed is c. The electric field is given. The electric field function is given, and as we discussed earlier, whenever we have the inside the sign a kz minus omega t, this actually helps us determine in which direction is the electromagnetic wave propagating. So if you have k z minus omega t, that just implies the wave is traveling along positive z direction. Okay, so this wave is traveling along positive z direction. Now the unit vector attached to the E vector is j cap. This is the direction of the electric field. Direction of the electric field. So we can just directly look at the electric field expression and find out in which direction is the wave moving and in which direction is the electric field pointing. Okay. Now the question is, we have to find the magnetic field function. Okay. So there are two things here, the magnitude of the function and the direction. Okay, so we'll talk about them one by one. So for the magnitude, we use a simple relation E equals BC, where E and B are the electric and magnetic field magnitudes. Okay, the thing that comes before the sign function, basically. So from here, B just turns out to be E divided by C. So basically 54 divided by 3 times 10 to the power negative 8. This will be the magnitude. This will be 18. So 18 times 10 to the power minus 8, or 1.8 times 10 to the power minus 7. Okay, so B and C are wrong because the magnitudes don't match. Now let's talk about the direction. The difference between A option and D option is that in A option, the propagation direction is along minus I cap. The magnetic field is along minus I cap. And in D option, the magnetic field is along plus I cap. So we need to determine the direction of magnetic field correctly. So let's say this is the x direction, this is the y direction, and this is the z direction. Okay, positive x, positive y, positive z. So we saw that the wave was propagating along the positive z direction, right? So we'll mark this direction as V cap. V cap just means this is the direction in which the wave is propagating. The electric field was along the positive y direction. So electric field is along this direction. Okay, this is the direction of electric field. So this is a simple straightforward fact that you guys should remember, is that the wave propagation is along the direction of E vector cross B vector. So of course E and V and B are mutually perpendicular. So if V is along Z, E is along Y, then B will be either along plus I or minus I. So let's extend this. So this will be minus I direction, minus X direction. So the magnetic field will be along minus X direction, because if you do E vector cross B vector, this is Y cross minus I, the answer is Z. If you do E cross B, you should get the direction of wave propagation. Okay, so the magnetic field will be along the minus I direction here. So in fact the answer will be option A, okay, and not option D, because of the direction thing. Okay, so thanks for watching, guys. This was the first lecture. So there were like 40 problems or something which we discussed. So I will soon come with like more lectures. So all the best for your exams. Okay, so I know a lot of people will have exams soon. So it's 6:30 now. So yeah, all the best. Short topics. Well, it's hard to tell, you know, like I'll do some more analysis and maybe I'll come talk to you about that. But what I'm seeing is there is a lot of electromagnetics that is being asked, right? There is a lot of current electricity, electrostatics. So those topics are being asked a lot, more than usual, right? Yeah, you're welcome, guys. It's my pleasure. So yeah, I guess that is it for today. We'll soon meet once again. So yeah, that's it. हेलो सर, लेक्चर फिनिश हो गया? नहीं नहीं, मतलब फिनिश हो गया, खत्म। ओके, बढ़िया था, बाकी सब अच्छा अच्छे से करने किया। हाँ हाँ, ओके सर।